Who is interested in going over native array methods? I just want to get a sense of who's here for it. Okay, cool. So I can talk to you guys. Perfect. So, okay, Matt's here too. Who? So before I get started, I just want to know what you guys want to go over. What specific things, so I can target those things.
I mostly don't want to be specific. I just want to hear it.
Okay, cool. Just want to be here and kind of just learn more.
Well, previously you had mentioned that you can do everything with reduce.
Yeah.
So maybe not like that part of Jeff and reduce, but just show us like what reduce is good for, what map is good for. I mean, I understand what they do, but like where you would use this and where you would use that.
Yeah.
Because I think you can do anything with either of them. So.
I like it. So I'm just going to go ahead and type it up here. So we'll do questions. When would you use which one? I like it. Other stuff that you guys want to go over? Anything specific?
We're only going to do one here,
No, I can do all, like, there's no format to this. We can do all of them if you want.
Just initializing the reduce as well.
Yeah.
That's pretty confusing.
I can definitely go over that. You guys good with that? Okay, let's just talk about this. So, when you use each one, so if we take a look at the ones that we have here, so every and some, I like to group them together because they have some sort of purpose with it. So, what would you say every is for, in your opinion? Well, when would you use every? What does it seem to be the purpose?
When you want to see if the array, every element of the array meets some condition.
Exactly. So every will be, it loops through the list and will return either true or false if every item in it meets a certain condition. That's all the purpose is. So like when you would use it for whenever you have a list and you want to make sure every single item meets a certain criteria. That's a long-winded explanation, but it does happen when you want to make sure, hey, does every single one have this property in it? And then it goes to check every single item, see if they have that property. Or whatever criteria is. Does every single one of these have a name? Or does every single one category is rock? Or something like that. So it goes through every single item, make sure the category is rock for every single one. If it's not, it returns false. Right? And same idea with sum. Sum is that purpose where if you have a list of numbers, you just want to see, hey, is one of them in there this certain criteria? So what it does, it loops through it and it returns true or false if it finds it. Which is good to know. For example, here we have this top example where we have numbers, right? It's checking to see if any of them is negative. So it goes from 10, 20, 30, 40, 50. It's like, oh, that one's negative. It returns true. Now, if, for example, this one was negative, it will go, is this negative? No. Is this negative? Yes. And that's it. It kills the function and returns right there. It says true. There's no point in going forward because some item, it already found one, is negative.
Will it tell you which item it defaulted on?
Nope. All it does is return true or false. Yep. It's just, that's as basic as that goes. Great. So that's every and some. It's just you just expecting a true or false. You just want to go through it. Like, hey, is this true or false? Like, is every item in this meeting this criteria? There's one of these items in this list meeting that criteria. That's the purpose of those two. Cool. Moving on. It's not in here, but for each is another one. For each is just as simple, like you have a list, you list that for each. And just like the other ones, it iterates for each item. For each, the difference is that it doesn't return anything. So for each, the purpose of it is just a loop. Just like you would do a for loop. And it has access to index and the array.
Does it do anything to the things?
Nope. Doesn't modify. It just loops through it.
So what would we use it
Anytime you use a for loop, you can replace it with for each.
So if you wanted to make a new array, you could, at each point in the loop, do something to the
Yep.
current item and push it into a new one, but
So
you're not going to modify
for? So
it.
anything that happens in there is just like it's happening for each iteration.
So we can refactor something like if we had a for loop and like for loop and we have a list of groceries. I don't know why that came to mind. We have a bunch of groceries. So what we're doing is we have bar new groceries, and it's an array. And what we want to do for each grocery, we want to append new groceries that push this one, right? So what we're doing is for each grocery, we're just pushing it into this new groceries list, right? You can do that with for each, same way. You would do groceries that for each, and then for each grocery, you want to go ahead and push it into new groceries that push into that. This is the same idea.
So like you never have to run for it.
Yeah.
Yes,
Can you do nested for each loop?
of course. So say each grocery is an array. That makes no sense. But you can definitely do something like grocery that for each and keep going with it. I don't know what the item will be in there, but yeah. But for each is another one. I don't know why it's not here. Maybe because it's just a simple loop. But that one's a good one to know. Just a loop. Great. Let's move on to, in my mind, is filter. Filter. How do you guys define it? What is filter? What does it do?
Creates a, I want to say subarray.
Uh-huh.
It's not what the word is. New.
It just creates it like a
It
new,
creates a new array, but it's
like a filter, right? I mean,
of the. There's a word for it.
like a subset, like a
subset.
okay.
Thank you.
Yeah, exactly. It's like a smaller version of the big array, right? Of the initial array. So it's never going to be bigger. It's never going to have any of the items. It's either going to be the same length, the same identical, or smaller, because it's filtering.
It returns something. It returns the things that are filtered.
Exactly. So it returns a new array. So it takes an array, and it's either going to be the same length or smaller, but that's what you get returned. So in this example, it only gives you odds. 44 is not odd. I'm like, that is odd. But yeah, let's go to the next one. This one, like if you're filtering by the ones that has the ID of 42, it'll give you this array. Now, this one's a little bit tricky though, because it's trying to filter for the one that has ID 42, and it's not going to give you this. Filter will not give you this. It always gives you an array. So it'll give you this right here. Right? Filter will filter something, but it'll always give you an array. Takes an array, gives you an array. Cool. So for this example, they probably want you to do like return languages that filter, and then we write a function where each language, and this is how I would do it. I like to have the item instead of being item for each one. Like, what is it? Well, it's a language. So we want to do return. So it's going to either return true or false, right? So return language that ID equals to the ID that you get passed in. So again, what type of data is this going to be returned from this filter? An array. So we don't want that. So we want the first item from it. So we can do something like that. Super trippy, but we can do something like that, like var filtered languages equals that, and then we can do something like return filter languages bracket 0. So we get the first one. Same idea as we just did with the other way. You just know that this right here is going to return an array, so you can do bracket 0 at the end of it and return that. Cool. Either way.
Sorry,
No, go for it.
what's the rule for having the double return? Or for having
Double return. Oh, yeah, that's a great point.
Because you're returning a function, but in the function you have to have a return, or it doesn't do it.
Yeah. So To really, yeah, so to really grasp higher functions like this native array method, like filter, random, reduce, you need to understand higher functions. So this right here is basically a function right here.
Right.
And this is some sort of, in a filter, this is some sort of predicate. A predicate is something that will like either meets the criteria or it doesn't. So in here, we can do something like var predicate equals that. So we define the function down here, and that's what we're passing it. This predicate is going to be a function that is going to be filtering it. So now you can see that there's only one return in this function.
Mhm.
This return belongs to the other function.
So how does it not break that chain when the
When
one
it's
on the
nested?
inside
Yeah.
returns?
It is a scoping issue. So like this return belongs to this function, and it doesn't affect this function
Okay.
because it returns this function. Cool. Let's see if the test pass. Well, there's a lot of tests anyway. Well, we got one passing, wherever that filter is. There it is. Cool. So that will do it, right? So filter, super useful. Guarantee you'll use it later on. It just takes a list, makes it shorter, gives you a new array, meeting some sort of predicate. Cool.
Can you just explain what the zero index is outside of the?
Yeah. So if we do something like this, return languages without the zero, what type of you said it? We're expecting.
Well, I understand what we're doing, but like, where does that come into the code, and where does that
Yeah.
pick up, and it knows that we want the first.
Yeah. So let's run this test again. We're gonna have to go through the list of things. Somewhere it should be failing.
Yeah, zero.
Zero passing, and somewhere in here it's gonna tell you I expected. Here it is. I expected this to equal this. Do they match? No, because one of them is an array, the other one isn't. So what's happening is that this right here returns as an like this pretty much was an array. So we know it's going to be one thing, so we want the first thing in this array. So we can do bracket 0 to access just the first thing before it returns it. It's the same thing as doing what we had before. Var list equals that, and then we return list bracket 0.
So that's actually it's our return statement.
Uh-huh.
Just shorten it for it.
Yeah, it's just a quicker way. Like before you return it, I just want the 0 one. Yeah, you can change stuff. That's how chaining method works. Is like you can add stuff to it. Mm-hmm. Yeah. So like if we wanted to access, for example, the name of it, here's a super long way. So like you can do something like return, but if you wanted the first one, and then you can do that name. This whole thing equals to closure, right? Because accessing the first one is more specifically asking for the name. That is like a chaining approach. I would discourage it because it's really hard to read. Cool. Other questions? Cool. So that's filter. We've covered every, sum, for each, and filter. So there's two left. Map, another one that you will use a lot. Map will always return you the same length as the array that you ran it through. So for example, this array right here has a total of 3 items, and the output is going to be a total of 3 items. So map always returns the same length. But a new one. Yeah, all these functions do not modify, they always return you a new one. So this one right here, the same idea. It's an array of 3 arrays, but it's an array with 3 items. You get back an array of 3 items. If for some reason you want to take an array of certain length and get another one of a different length, you can't use map. That's not the purpose of map. Map is I'm going to map through each of the items, like I'm mapping through the list. So I'm going through each iteration, and I want to do something to it to change it. Cool. So let's do one as an example. This one right here, it says we take this array, and we expect this one to out. So we want to go and list through the candies. So we're going to do return candies that map. Just like the other ones, you have a list. So each candy, again, I like to be semantic. This is a candy. if we're looping through candies. We want to return a new item. So we take the candy, we take something like this is the candy, we want to return something like that. So now what we're dealing is with an object. So I'm going to do var new candy is going to be an object. And what I want to do is the new candy dot name is going to be equal to the candy, the first item of it. So candy of 0. And I'm not going to return that just yet. I'm just candy, thank you. So new candy dot price equals to candy bracket 1, and new candy dot quantity equals candy. Are you giggling because I said titties? Okay. Return new candy. There we go. So, what is this doing? Well, for each of the candies that we have, for each item, we're going to create a new object, and we're calling it new candy, and we're editing, we're sort of building this object, and we're going to return it. What we return is going to take place for whatever we had before. So it's going to take place from this. This is going to take place. So if we go ahead and run this, you'll see somewhere that, yeah, I don't know which one it is, to be honest. To object, I think that'll be it, yeah. But what happens, for example, if I just return something? What happens if we map through this and we return something for every single one? Yep, exactly. So if we run this, we'll have, hey, I expected, so we have an array that just says something, 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 because we replace each index with just a string of something to be equal to this. Yep. So that's what we want. Questions about map? Map is great if you just want to edit each item, like you just want to do something to it, to each of the items. Great. All right, last but not least is reduce. Reduce, when will you use reduce? Many situations. Reduce is super powerful and can do anything. It's when you want to take a list and return whatever from it. You just want to take a list, loop through it, and return whatever. That's what reduce is for. So if we, and I'll do both of these just to kind of example. So I'm sure we're going to return matrix.reduce, and we're going to have some sort of values in here. So what are we trying to do? First thing I always do with reduce is think of what is the return value. So we take this list, what is our output? Another array. So what I do is I want to initialize it with an array. So reduce is the only one that takes in 2 arguments. And actually take 3, but we're not going to talk about the third one. But actually, they take in 2 values. So if it's easier to think of this, it's a function. We'll call it logic, and it takes initial value. Right? So what we're calling is the initial value to be an array, and we're going to do function to be some sort of logic, right? But for the sake of the purpose of this, we're just going to write it in here. So reduce, we have function and the initial value. So reduce, the first one is not actually the item on each iteration. It's actually the returning value. So I like to call it the accumulator. The accumulator is what you're going to return at the end. But what is this? I actually don't know what this is. Like, I try to not call it accumulator because that's a very generic name. But what is, I don't know, it's like a new list or, yeah, new numbers or something like that? Yeah, I don't know. So, I don't know, numbers list? Whatever, it's just whatever the output is. Maybe output list or something like that. And then the next one is each of the items. So we're gonna call it like just each list, because these are a list of numbers, right? So this one again is whatever you're gonna output. It starts out as an empty array, and this one is each of the items. So what you return in a reduce is the accumulator. So you return it every time. So in this case, we want to return at the end the numbers list. We already know that. But before we return it, we want to do something to it. What are we trying to do to the numbers list?
Get them out of their arrays.
We're trying to look at this list and push every single one of them into here. Right? So if you notice, it goes 10, 20, 30, 10, 20, 30, negative 10, negative 4, negative 10, negative 4, 0, 10, 20, and like it just appends whatever it has. Right? So the lengths of them differ. So basically we want to loop through all of them, right? So we can do a for loop, but we actually just learn a new way to for loop, which will be what? For each. So we do list.for each, and what we want to do for each of the item, so these are numbers, we want to push it into numbers.list. So we do numbers list that push the number. So we take the list that we're given. For each of those numbers, we're going to push it into the new list. The new list starts out empty. So if you go ahead and log it, number list, and actually let's add index in here, just for the sake of visualizing it. You will see that for each iteration is appending each of the numbers. So in the first iteration, we append 10, 20, 30. And this is the first iteration. In the second iteration, we append the other two. In the third one, we append the rest. In the fourth one, there's nothing to append. So it just, since there's nothing here, it just returns the same one. And then at the end of the loop, it just returns the result. That's reduce. You can do anything with reduce. So you can map, you can filter, you can average, you can sum, you can do any of this stuff. Let's do the other one and then we'll take questions. So what you're trying to do here is take a list of phone numbers and return some sort of catalog? I don't know. So what we're going to do, again, for this setup, we know we're going to reduce. So we're going to do numbers that reduce. And then we take a function. And what's the first thing we do with reduce? Right. Think about the initializer. So the initializer, what's it going to be? The output type. What is the output type? Object. So I would simply just do here. I want an object, so I want to start with an empty object. Nope. So, and then that's going to be, I want to call it a catalog. I don't know what that, whatever this object is. I want to call it catalog, or like, yeah, because it has a bunch of phone numbers in it. I don't know. And then each of the item is going to be a phone number. Right? This is a, I don't know if it's a phone number, maybe a, I don't know, phone numbers? Whatever. Whatever this you would consider this to be. And the expected output is this catalog thing that we're creating. So I want you guys to help me through this one. What do we return from the reduce for each iteration? What is it that we return every time? What are we returning? And this is the previous example. What do we return every time? An array, but what array? The number list. And what is the number list? The accumulator, yeah. So in this one, we want to do the same idea. We want to return the accumulator. So what's the accumulator in here? Exactly. So we'll start with return catalog. That's what we want to do. But before we return catalog, we want to do something to it. So what do we want to do to it?
So it looks like we need one object that's split into two arrays, one small and one large.
Excellent. So
What the loop does.
yes, so we get something like this, and we want to add the home to the catalog, to the home, and the cell to the cell, right? So you notice how the 555, 655, 4555 is the first one. and likewise with the other one, 2, 3, 3, and it kind of goes like that for each one. So I don't want to get too hung up with the logic of this, but basically we want to do something like, hey, if catalog that home, like, does that even exist? So we want to need to check it, because we can't just do something like catalog that home that push phone numbers that phone that home, right? We can't do that because it's going to say home is not defined. Catalog at the beginning is just a plain object. You can't do push and undefined. So what we can do is, hey, if catalog.home, if that exists, let's go ahead and push into it. What would we do if it doesn't exist? Push into cell. Well, the thing is that cell also.
Or push cell into the catalog.
I don't think we're there yet. So what's happening is like catalog.home doesn't exist. So this is our catalog. It's an object.
So you want to create
Yeah.
that value, the key.
Yeah. So let's do catalog.home equals to what? An array. Then after it's defined, we can go ahead and push it to it, right? Now, to be lazy, we're just going to go ahead and do the same thing to cell. Now, this will work. We'll refactor it in a second, but that's all we're doing. We're just taking, let's see if we can do this logically. Hey, does catalog.home exist? The first time is not. So it's going to go make catalog.home an array. So this is an array now. And we're going to go ahead and push it to it. The phone numbers, which is this, that phone, which is this object, that home. So we're going to push this number. Then we do the same thing for cell phone. Make this an array and push this one. The second time, does catalog.home exist? Yeah, we have an item in it. Okay, cool. Then just push the next phone numbers, that phone, that home. And it goes through that, like that for every single one. So let's go ahead and give this a try. We'll see that I don't even know. Consolidate. Cool. It works. Right? Yay! We got it. But this is very verbose. Wouldn't you agree?
So phone numbers is essentially the index of.
Exactly. That's what we call it. You can call it like item, like every single item in the list. You can call it whatever you want to call this, basically. What is that? I don't know.
In the docs, they usually call it the current value. If
Yeah.
you see that in documentation, that's
Yeah, sometimes you will see something like this is previous and this is next. I think that's terrible. I like more of like this is the accumulator and then this is
what you're building.
current value. Yeah,
That's what you're going to manipulate
Mhm.
into the
exactly. Yeah,
Yeah, I think it makes a ton more sense when you explain the accumulator. This is what you're returning, and this is what we initialize. Like,
that's how I would do it. That's how I personally do it. Like, okay, I'm going to do reduce because I want to take this list and return something new. What does I want to return? I want to return a string. Cool, let's initialize with an empty string. Cool, now for each item, how am I going to build this string and then return that string? Basically the same idea. So I like phone numbers and catalog because I know what I'm building and I can keep in mind that this is the accumulator, this is each item in the list. Now this is very verbose. We can simplify by, notice how this line and this line are identical, right? We can move them out and delete this. Oh God. And delete that line, right? Now if we make this the opposite, we can simplify like this. We'll do it one more time for this one. Since this line is repeated here, we can move it outside the for loop because it's going to happen no matter what, right? So we do that and then we can delete. Why is it happening? Yeah, we can delete it from the list. So now, but you never want to have an empty if statement. You can just make the opposite of this one. So we're going to make the opposite of that, and then we're going to remove this. Now what we can do is push this down, and then we have a little bit cleaner code. You can simplify this even more. You can do something like catalog home is going to be equal to itself if it exists. If it doesn't exist, it's going to be an empty array. Right? So if this is undefined, it's going to be equal to an empty array. So now we can go ahead and do that for both. So catalog.home is going to be equal to catalog.cell, or an empty array if it's not defined. And that's a little bit cleaner. Right? Saying define if it's not there, and then push the new thing. Questions about reduce? How to use it? Yeah.
I hope this will apply for everyone. Since you can technically do anything with reduce, how do you personally, or how would we decide when it might be better to do a map rather than a reduce? Or is it more of a personal preference?
No, not at all. I would prioritize map or filter
First.
before reduce. Yeah. So like if all you're doing is you're returning an array of the same length, right away you should know you got to do map. Like if you're returning the same length array, do map. If you're returning basically the same list, but it's a little bit shorter, then I will do a filter. If you're not editing anything, if you're not returning anything, all you're doing is just looping through it, do it for each. If you're checking something like, it's just basically when you're taking a list and returning something completely different. It could be an array again, but it's a different formatted array, and it's a different length or something like that. That's when I do reduce. Reduce is when you have a list and you want to convert it into something, some sort of formatting, into something new. We can do this with anything. If you guys want, let's do no more tests. We can touch example.js and we can do any kind of stuff. So if we take this list, for example, and what we want to do with this list is var candies equals that. Let's do a reduce with it. I want to log a result. So how do we add up the total from this list? How would you guys go through this list of candies and add up the total price of it? How would you guys do this, person?
I guess just the idea of a map and only returning the prices
And then sum this from there, yeah. I can do that really quick. So we do something like var, oh, thank you. Cannot tell you many times. Run out of juice. Var, let's see, candy price equals to candies that map. So we're going to map through each one. And for each of the candy, we want to return just the candy one. That will give us the price. And then we can do something like var result equals 0. And then to add up each one, we do candy price that for each function, each of the price, we're going to result plus equals price. Right? So we take all the candies, we map through it, so now we have a list, and let's log it. Candy price. We have a list of just the prices, and then for each one, we're going to go ahead and add it together. So if we go ahead and run this, we get the total price.
Why do map in the first place if we're going to run for each on it?
Right. It seems a little redundant, right? So we can go ahead and simplify all of this. We can just do this maybe like with a for each, right? We can do something like candies. So this is our first approach. Let's do it again with just one loop. So maybe we do something like var result equals 0. And we're going to do candies that for each, and then each candy, we want to do result plus equals candy of 1. Right? So we're looping through each of the candies. We're going to take the first one and add it equal to result. So that's a little bit simpler than what we had before. Right? But we can simplify even yet more with reduce.
Yeah.
So var result is going to be equal to candies that reduce. So let's do this one together. What's the first thing that you do in reduce? Initialize. What's going to be our initializer? Why?
Because we haven't added any prices.
Correct.
And that's what we initially did.
Right, and that's what we use for the other ones too. What I would say is, great logic. What I would say is, our result, we want it to be a number. So the most basic result is going to be 0. If it was a string, I would do empty string. If it was an object, I will do that. If it's an array, I'll do that. But this one, we're going to start with 0 for the number, right? So what's the next step on reduce? We want to define the 2 parameters. So what's the first part? Yeah, you can call it result if you want. Yeah, let's call it total, just so a different variable name. So that's the total, accumulator. And then what's the next one?
Oh, current value.
Or candy.
Candy. Right, the current value is going to be each item in the list. So this one is going to be each candy, the current value. So for each one of them, we want to go ahead and do, and what do we want to return in the reduce?
Price. Candy one.
So if we return candies,
Oh, yeah. Total.
yeah. So we want to return the total every time. We want to with reduce. 99% of the time, you will return always the accumulator. But you want to modify it before it. And yeah, this is the price. What do we want to do with the price? Add it to total plus equals candy. Oh. There we go. So that would be with reduce. I mean, it's about the same line numbers, but cool.
Yeah, but I understand one.
This is pretty simple. I don't know what you're talking about, Nick. Yeah. So reduce, you have a total accumulator, you have each one, and you return the accumulator as it goes, you do something to it before it, and then the result's gonna be the same. Now, there are times where the initializer is not an empty string, there's not an empty object, there's not 0. For example, if you were trying to multiply all the candy prices together, if you do times equal, yeah, you have to set it to 1. Exactly. So there are times where you would have some sort of accumulator. So like, say we wanted to reduce this list, and this will be the last example. We want to reduce this list to a sentence that says, I got the following I got a dark chocolate crunchy, peppermint poppers, and banana bunches. So we want to create a sentence. So to do that, you would do something like var result equals candies that reduce. Now the result is going to be a string, but I want to start it with I got delicious candies, and then that's our initialized string. So we're going to see something like this is a sentence that we're going to return, and for each candy we want to do sentence plus equals candy 0, and we probably want to add like a space or something, comma space, I don't know, and then return sentence, and I think it's going to be it's going to have it at the end, but now you have, I got delicious candies, dark chocolate crunchies, peppermint poppers, banana bunches, and it kind of keeps going. You have to have some logic to edit the last one, but the point is there that you can initialize it with whatever you want. If you leave it out, this becomes the first item in the list, in the array. But I would just get in the habit of including it, just for now. Alright, that is my spiel for this.
Yeah.
Any questions? Anything we're good? Okay.